Welcome to the fourth day of our week-long C++ bootcamp. We have some very cool material for you today. We're going to cover writing games, the sort of game you can make for a mobile phone. As a quick recap, the first day we covered making your first app with C++ Builder. The second day we looked at making amazing user interfaces with some cool effects. The third day we had a quick introduction to C++, and then upgraded some old C++ code to modern C++, and had a fascinating conversation with Patrick Scheller of the C++ Google Plus group and Bruno Bebé, one of our compiler engineers, on all sorts of technical topics. Today's session on games is presented by Eli, one of our MVPs and a developer experienced in many languages and platforms, and an avid gamer. He's developed some great games using C++ and is going to talk about the games and how he built them. Over to Eli.
Hey everyone, this is Eli M. from fmxexpress.com. Just some information about me before we get started. I have deployed over 300 mobile games across Google Play, Apple App Store, Amazon App Store, and Samsung apps. I have also aggregated over 80,000 plus Flash games to 120 plus million players worldwide, reaching over 210 plus million gameplays. And with fmxexpress.com, I have reached over 400,000 developers with hundreds of tips and tricks for FireMonkey. We are going to be covering 4 different games built using the FireMonkey framework in Rad Studio C++ Builder. The games run on Android, iOS, Windows, and Mac OS X using a single UI and single codebase. On Android and iOS, FireMonkey uses OpenGL ES, on Mac OS X it uses OpenGL, and on Windows it uses Direct2D or GDI+. There are 2 versions of the games available. The first version utilizes new language functionality available in C++11 like lambdas, auto, and unique pointer. The second version compiles under the classic C++ compiler which supports Mac OS X. The games themselves are based on classic arcade game mechanics and include Alien Invasion, Mars Rocket, Rocket Ship Delta, and Space Rocks. Alien Invasion features a grid of enemies which fall towards the player that the player must destroy. Mars Rocket features an inertia-based rocket that the player must successfully land. Rocket Ship Delta is a side-scrolling game where the player must defend a planet from attack. And Space Rocks has a group of asteroids that the player must break up and destroy. Each game has its own mechanics, but are all based around the same architecture. We will highlight each individual game and its unique mechanics one at a time. During each highlight, we will talk about 2 different architectures or framework features that are leveraged throughout all 4 games. The architectures and framework features we'll be using are T-Rectangle as an image container, using frames for UI, utilizing the motion sensor, saving high scores using SQLite and live bindings, simple object pooling, sprite sheet animation, app tethering, and cross-platform sound. The games are built using a rapid application development style designed for fast iteration and quick time to market. The games were designed around the idea of a game loop, which is a heartbeat for the game. There are other ways to build a game like using a message system or using threads, but in this instance I simply use a T-timer control set to 36 milliseconds. Most of the actions within the game take place during the game loop. The player's actions change various Boolean variables, and those variables are used during the game loop to affect the game. If the code within the game loop takes longer than 36 milliseconds to execute, the player may experience lag, so keep that in mind when you are optimizing the game loop. Within the game loop, it processes game events like game over and level complete, the player inputs including the accelerometer, explosions and projectiles, enemy movements and events, and power-ups. Finally, it handles collision detection for all entities and looping the music. You could refactor the game so that the game loop is within a thread, or there is another trick you can use with a game loop, where if it takes longer to execute than the time until the next frame, in this case 36 milliseconds, you pause the game loop execution and resume it where you left off in the next frame. So if you were looping through explosions and you reached 36 milliseconds, you would record where in the loop you were and then exit the game loop at that point. During the next loop execution, you would start up again at that same loop increment instead of starting over at the top. Both of these types of optimizations can greatly increase the complexity of the code though. There is an if-def setup called debug mode, which is currently enabled. When enabled, it displays the current cost of each game loop in milliseconds on a T label. You can disable in the code before deploying the game to the various app stores. All 4 games can be controlled via the keyboard, mouse, touchscreen, or accelerometer depending on what input types your device supports. The possibilities for expanding and mashing up these games into new games is almost limitless. So I am also going to share with you some ideas with each game so that you can jump in and start modifying the games right away. The first game we are going to talk about is called Alien Invasion. Alien Invasion is a classic arcade-style game which features a grid of aliens that move and sync back and forth across the screen. They fire projectiles at the player, who is at the bottom of the screen. On each trip back and forth across the screen, they start moving faster and faster. There are 4 shields near the bottom of the screen that the player can hide behind, but they have a limited number of hits that they can take before each shield is exhausted. The player can only move back and forth at the bottom of the screen and fire projectiles upward. Only one player projectile can be active at a time, so if you miss, you must wait until the projectile leaves the game space before firing another projectile. There are also 2 special bonuses that exist within the game. One is a random spaceship which moves across the top of the screen, and then the second is a points power-up that randomly moves around the screen. So I have Alien Invasion open in Rad Studio C++ Builder here, and I'm going to compile it to Windows and click play, read the instructions, and then I'm going to use the keyboard to play some of the game here. You can see there's the enemies. I'm firing at them. There's the shields down at the bottom that I can blow up. I can switch to the mouse and move back and forth with the mouse. I can fire with the mouse, and then I'm going to just clean up the rest of these enemies so you can see the level complete screen using the keyboard. And you can also resize the window like so, and here's the final enemies, and level complete. I'd like to share a screenshot of an early version of Alien Invasion so you can see it in its skeleton form before the graphics were applied. You can see how T-Rectangle is used. So here is the enemy grid. Here are the enemy projectiles. The player is down here, the left and right button, the shields, and the fire button. We are going to cover the basic building blocks of how I put the games together using the Form Designer and the various FireMonkey controls and components. The most basic building block is the humble T-Rectangle control. Let's talk about using the T-Rectangle as an image container. The T-Rectangle control is the cornerstone of most of the objects within the games. This includes things like the menu buttons, the player character, the enemy characters, and the various projectiles and explosions within the games. T-Rectangle is a very versatile control. I chose T-Rectangle because it is able to display a bitmap like a JPEG or a PNG, and it is more lightweight than T-Image. The dimensions, rotation angle, and position of the T-Rectangle can easily be accessed when building collision detection as well. You can modify the look of the T-Rectangle control using the fill and stroke properties. The fill property is the face of the T-Rectangle, and the stroke property is the line around the edge of the T-Rectangle. Setting the T-Rectangle stroke kind property to none will turn off the line around the T-Rectangle. The T-Rectangle fill kind property can be set to bitmap, which will paint the face of the T-Rectangle with the bitmap property you set up as a T-bitmap brush. The T-bitmap brush has a wrap mode property, which controls whether the bitmap will be tiled or stretched to cover the face of the T-Rectangle. In most cases, I use the tile stretch setting for the wrap mode within these games. So in C++ Builder, I'm going to click on one of the enemy T-Rectangle graphics here, and you will see that enemy is selected over here. It is a T-Rectangle, and we're going to review some of the properties of the T-Rectangle, which I just talked about. We have fill property right here. It is a brush. There's a bitmap brush here, and there's the wrap mode set to tile stretch. If I open this up, you can see the image that's loaded up into that fill, and you can see that the kind is set to bitmap here. And then we're going to show some of the other properties. We have position, there's the X and Y. The height and the width is here, height and width. And then you can hear is the stroke property. Now, in the design part of the game, I have the stroke inside this layout set to dash so that you can see that that is a object that is set up at design time, but the dash will disappear using code at runtime. On the main form of each game, I have an asset layout control, which is a T-layout. A T-layout is an invisible control which you can use to manage your layouts. Inside the asset layout, I embedded the various game elements like the enemies, projectiles, explosions, and power-ups using T-rectangle. This saves you from having to write all of the code to load those bitmaps at runtime. The asset layout control simply gets hidden at runtime, and you can access the bitmap elements as needed. Some elements of the game, like the player character and the game backgrounds, are not stored in the asset layout. Instead, they are set up at design time exactly how they will appear at runtime. So in C++ Builder, I'm going to select the asset layout control. You can see it here. It has all of these different controls: the collect item, the enemy 1, 2, 3. That's these controls here, 1, 2, 3. The health bar, the explosion, the projectile, the saucer projectile, and the shield or wall. So that's all the assets within the asset layout. And then at runtime, it's just hidden so you don't see it. In FireMonkey, animation can also be handled through the T-rectangle control. One example of this is the explosion animation. First, I created a T-rectangle, then I dropped a T-bitmap-list animation on it. The T-bitmap-list animation component uses a sprite sheet bitmap for animation. A sprite sheet is all of the frames of an animation combined into a single image. The component then copies out each frame of the animation from coordinates on the sprite sheet one frame at a time to create the animation. In this case, the animation targets the fill bitmap property of the T-rectangle. T-bitmap list animation has a lot of different properties, but I only use a few like animation count, animation row count, duration, and trigger. The trigger property watches for a property change, like if the isVisible property gets set to true, then the animation starts. The game control buttons and other visual display graphics within the games are also built using T-rectangles and visually added directly to the main form at design time. The rest of the interface screens are built using frames. You could enhance the game to use a custom T-rectangle, which might be implemented as a platform native object for increased drawing speed. So I'm going to select the explosion T-rectangle over here, and you can see that the animate explosion T-bitmap list animation is applied to that object. And if I bring up the graphic for it, you will see here is the sprite sheet that I was talking about. Each of the different frames of the animation is on that single image, and then the other properties I was talking about here is animation count, animation row count, the duration, and down here is the trigger property with isVisible equals true, and it's all applied to the property name of fill bitmap. And if I unhide the explosion here, you will see that is the object that is being applied to. Let's talk about the UI in frames. If you want to provide a professional game experience for your game, you need to provide all of the standard game menus which players are accustomed to. The different game menu screens were built using frames. Frames are similar to a form but behave more like a component that you visually design. You can create a frame, fill it with other components using the standard form editor, and then embed the frame multiple times in your forms. This allows you to quickly design, modularize, and reuse your UI. In these games, I created 6 frames which include the main menu, the settings, the gamepad, the high scores, the instructions, the game over, and the level complete. So I'm going to show you the different frames that are in each game project. Here's the game over screen. You can see the layout, different buttons on it. The gamepad, the different layouts. Here's some non-visual components for tethering, and the high scores screen. Continue, and then the various non-visual controls that it has. Instructions screen. You can edit the text box here for the instructions. The level complete has a text box which gets filled in by the game. And the main menu, here's the logo of the game, the play button, the other buttons, and the settings page, which has these switches. And you'll notice that the styles are not visible on the frames themselves, but when you get back in and embed the games in the form, then you can see the styles applied to the frames. Generally, I use the align property to align each frame to content. The content setting ignores the other aligned controls and fills up the current parent control with the control being aligned, in this case the frame. For the UI elements like buttons that are on each frame, I use the anchors property to keep those elements positioned correctly regardless of screen size. In FireMonkey you can embed controls inside other controls, which allows you to create the exact interface you want. In some cases you will want to use a T-layout or a T-grid panel layout aligned to top or bottom to further segment your space and then embed other controls within them. Using this technique you will be able to build a universal UI that looks great on TVs, desktops, tablets, and phone-sized devices. So let's check out the align property and the anchor property. Let's check the gamepad. So what we have here is we have a T-rectangle inside of a T-layout control. And the T-layout control is aligned to top, and then the T-rectangle is aligned to left, and then this button is aligned to right, and in the center we have a T-label which is aligned to client. And client takes up the whole screen area that's not taken up by the other aligned controls. Over here we have a button, the fire button, and it is not aligned anywhere, but it is using the anchor properties and the bottom right anchor properties to stick in this corner of the frame, so that when you resize the frame it doesn't get left here. On any screen size it will stay in this bottom corner of the frame. Each frame is embedded in the main form and set to visible equals false. A set stage function was created to manage the current state of the game and handle showing and hiding the different menus. Most of the frames don't have any extra code embedded in them, but the gamepad frame and the high scores frames both do. It made for easier organization to keep all of the gamepad code within the gamepad itself. The gamepad allows you to control the game from other devices via app tethering, which we will cover later. So now I want to show that the various frames. So here's the game over frame, and its align is set to contents. And then if we go down to the visible property and we set it to true, you can see the game over frame taking over the whole screen, and it will show up that way at runtime when you set it visible to true. And so then if we go over to the set stage property or function, you can see the various stages that the game can have: main menu, instructions, gameplay, level complete, game over, high scores, settings, and gamepad. And so when that function is called, setting each of those stages, it manages the different frames visibility so you can control the game from code and the menu system. You could enhance the game UI by moving the player control buttons into their own frame, or even by moving all elements involving the gameplay into a new gameplay frame. This would make it even easier to create new games around the existing framework. Having the gameplay in its own frame would also allow you to load up different types of levels within the same game just by picking which frame to load into the current level. The second game we are going to talk about is called Mars Rocket. Mars Rocket is a classic arcade-style game where the player must collect points and land the rocket without crashing. On each level, 3 stars are randomly placed throughout the game screen, which you can collect for more points. Think of them along the lines of the mechanic in Angry Birds, where you can pass a level with only 1 star, but if you are really good, you can get all of the 3 stars. Along the bottom of the screen, a random number of platforms are generated in different sizes, which the player is able to land the rocket on. If the rocket is just slightly off, it will crash instead of landing. The player also has a limited amount of fuel in each level to land the rocket. The motion-centric controller really shines in this game, as it makes controlling the rocket very intuitive. So here I have Mars Rocket open in Rad Studio C++ Builder, and I'm going to walk you through the asset layout again. We have this screen, the interface background. I use that at the end of a level just to give it added flair to the graphics. There aren't very many graphics in this game. You have the player graphic, you have the stars that you collect, and you have the platforms that you get automatically generated at the bottom of the screen. Now the player graphic, you'll notice, is not inside of the asset layout because, as I said before, some of the assets like the player graphic are just placed right on the form where they're used. I do want to talk about the player graphic a bit here. If I click on ship, that's the player graphic. You will notice that on the tail of the ship, there is a rocket thruster. And so that thruster is controlled, the visibility of it is controlled individually from the ship visibility. And so when you fire the thruster, that turns on, and when it's not firing, it's off. So now I'm going to demonstrate Mars Rocket here. We're going to compile it to Windows 32. The game's going to load up. We're going to click play. We're going to read the instructions. You can see here is that interface background on the instructions as well. I'm going to click continue, and then I'm going to use the keyboard to control the rocket. I'm going to go collect the stars. I come back over here to one of the platforms and try not to crash. Here we go. And I've successfully landed the rocket. And then I got all 3 stars and moving on to the next level where I can collect the stars and land the rocket once more. I'd like to share a screenshot of an early version of Mars Rocket so you can see it in its skeletal form before the graphics were applied. You can see how T-Rectangle is used. Now in the final version I didn't use this exact same ground system. I used a different system, but the rocket still does collide against the ground. Here you can see the rocket, you can see the labels with the fuel and the velocity, the left and right rotate buttons, and the fire rocket button. Let's talk about the motion sensor. The motion sensor component within the FireMonkey framework in C++ Builder gives you access to the accelerometer data on each platform. Usually you will have these sensors on your iOS and Android devices. When the motion sensor active property is set to true, the accelerometer data is accessed during the game loop in the process accelerometer function. For Mars Rocket, the motion sensor is enabled by default as the game plays best when you use the motion sensor. Tipping your device forward will fire your rocket engine, while tipping the device left and right will rotate the rocket in that direction. You can enable and disable the motion sensor using the gyroscope button on the top right of the game. You might enhance the game to include more control using the motion sensor, or to allow the devices acting as the gamepad to send motion control sensor data to the game.
So I want to demonstrate the gyroscope accelerometer functionality. I've got Rad Studio C++ Builder here with Mars Rocket open. I'm going to go over here to the target platforms and I'm going to select iOS 32. I'm going to select my iPad and I'm going to compile it to the iPad. I'm going to grab my iPad here, bring it up into the space, and we'll see that it's currently linking and deploying the game to the iPad. I already have it. I already have all the 4 games on the iPad, but I just want to show you that it just deploys directly from C++ Builder to the iPad, and then you can start playing and testing your game. In a few seconds here it will be loaded up, and you'll see that I'll be able to move left and right with the accelerometer, and I'll be able to go in this direction, and it will move, and it will fire the rocket. So it's loading up the app on the iPad now and launching the app. Here we go. Takes a few seconds. FireMonkey's launched. Here is Mars Rocket. We're going to go at play. We're going to continue. And if I tip this way, you can see it fires the rocket. If I rotate that way, it rotates the rocket that way. Go this way, grab that star. I'm going to go over here and try to get this other star. And velocity there, you can see the fuel. Alright, now I've got all 4 stars, which is all the points I can get for this level besides the fuel. Now I'm trying to land my rocket, whether that's going to happen or not. Oh, I didn't make it. Alright, so I've got 3 lives here, so I'm going to still try to land my rocket without crashing. Come on. Oh yeah! Alright, so I got all 3 stars. You can see the level complete screen. And so the 3 stars here are in a T-grid panel layout. So that's how I was able to get all 3 of them spaced out across the screen. Move on to the next level. Each level is just harder than the last. I'm going to accelerate over there. And then you can see I can... Alright, I'm going to get my guy up here, and then I'm going to turn off the gyroscope. And you can see how it stopped. It stopped controlling the rocket when I turned that off. And you can also see one feature here is that when the gyroscope is firing one of the buttons, behind the button, let's see if I can turn. behind the button is a kind of a blue color. The button lights up, so you know which button is firing depending on what movement you're making with the gyroscope. And so all four games actually support this control, and so each of them has a different control, obviously. But all right, I landed again.
Let's talk about the high score system. Most classic arcade games had a high scores system, and these games are no different. Everyone likes to leave their mark and then try to beat their previous score. The high score system within the game is implemented using FireDAC and SQLite. The code for handling the high score system is within the high scores frame. TFD connection is used via a FireDAC SQLite driver link to access the SQLite file. The contents of the high scores list is accessed via a FireDAC table component and connected via live bindings to a list view control. FireDAC query components are set up for inserting and deleting records from the high scores table. Only a few lines of code are needed to hook it all together, which includes things like creating the SQLite database file at runtime. You might enhance the high score system to be pre-populated with high scores, or you might hook the high score system up to a server using the TREST client component so that the players can compete against each other's high scores on a regional or global level. So here we have the high scores frame in Mars Rocket, and we have the various non-visual controls here. This is the TFD connection control, the TFD table control, the two query controls, which are TFD query, the insert and delete, the binding controls, the SQLite driver control, the wait cursor, and then we have the list view over here, and the list view uses live bindings to connect everything. So we're going to bind visually here, and you can see the bind source, the name and the score connected to the item detail and the item text fields. And then when we click over to Mars Rocket, we're going to close this out. We can click on the high score frame, unhide it, and you will see the high score frame with the style applied to it. And now if we click back over here to the high scores frame and we switch over to the code view, scroll up here to the top, we can see after the scores connection connects, it creates the table if it doesn't exist. Before it connects, it creates the SQLite file. We also have a function add score. We have a save score function. We have an init frame function, which loads everything, connects, creates the file, all that good stuff. And that's it for the high scores frame. So now I'm going to show you the high score system in action. I'm going to compile it here for Windows. It's going to load up, and I can click high scores and see the various high scores set up in the system, all loaded up with live bindings from the SQLite file. And then if I play the game, I'm going to go over here. I'm going to try to get some score by landing my rocket. And I've successfully landed, got a score. And now I'm going to crash my rocket spectacularly. Boom, into the mountain. And I don't know what I'm doing. Oh, crash. And then finally, my third life, I'm going to crash again. Oh, this side of the mountain. Oh, and then I can enter my high score, Eli, and OK, and Eli gets added up into the high score system, and I can continue on back to the main menu. The third game we're going to talk about is called Rocket Ship Delta. Rocket Ship Delta is probably the most complex of the four games, as it has the most number of objects moving around, and it even has a mini-map display. Rocket Ship Delta is a classic arcade side-scrolling game, which gives you 4 directions of movement. In addition to a normal projectile weapon, the player also has access to a screen-clearing bomb and a warp functionality. The bomb is limited to 3 uses per game, but the warp has unlimited usage. The goal of the player is to stop the aliens from abducting the characters on the planet's surface and carrying them off. Once an alien carries off a character, it upgrades itself and then comes back for more, better, and stronger. On the left and right side of the game area, there's a wormhole which teleports the player to the other side of the game area. The background in this game is actually 3 different transparent layers which move based on the location of the player, creating a parallax effect. I'm going to walk you through the asset layout component again in Rocket Ship Delta. So here we have the asset layout. We have the different enemies. with their different animations applied. We have the player projectile, which if I can select these small little things, those are the different player projectiles. It actually phases between those different projectiles. We have the enemy projectile, we have the power-up, we have the characters that get captured, we have the bomb graphic, we have the wormhole graphic, and we have the plasma fence graphic. Here's the player character. And now we're going to compile Rocket Ship Delta here for Windows and test it out so you can see how it plays. And so here we've loaded it up. You got the mini map. Oh, I blasted that guy. I'm moving over here. I'm going through the wormhole. There's a power up. I missed it. There's some more guys. Oh, he's chasing me. Blasted him. Oh, that guy's here. He's capturing one of the characters. Oh, I'm using my bomb and destroy him and use a warp. Oh, another bomb. Go through the wormhole. And that's pretty much how it plays. Oh, I'm gonna get crushed here in a minute. I'm not firing. Oh, take all these guys out. Oh, I saved that one guy. And then here at the edge, you can see the plasma fence. That was the bar at the edge. It stops you from going outside the play area. And there's level complete. Now you notice that I'm testing these here on Windows, but if we go over here to the target platforms, you can see that I can also compile it for Windows 64, I can compile it over to Android, I can compile it for iOS, iOS 64, and Mac OS X. Now the reason why I use Windows, I mainly use it for testing and debugging purposes because it works fast and you can quickly debug and iterate, and then when you're ready to go over to Android and iOS, then you can go over there and test for performance and optimize and things like that. And so I find it best to just program it on Win32, and then when you're ready, then you can start deploying it on those other devices, which takes a little bit longer to deploy, and so it's easier to just test it out on Windows first. I'd like to share a screenshot of an early version of Rocket Ship Delta so you can see it in its skeleton form before the graphics were applied. You can see how T-Rectangle is used. So there are all the different enemies flying around. Here's the player. Here's the different projectiles. Here's the buttons for moving left, right, up, and down. And then the fire button over here on the right. Let's talk about object pooling. Creating and destroying objects on mobile can be expensive performance-wise. The T-string list component was used to implement a simple object pooling system. When the game is initialized, all of the object lists are created. If a new object like an enemy, explosion, or projectile is needed, it is created and added to a list. Once it is no longer needed, it goes back into the list for reuse later. Looking objects up by string is not currently used, but is available for future use if you're going to add special types of enemy characters, for example. At the end of each game, the lists clean up all the objects and are then removed. The string list has a property called ownsObjects, which will automatically clean up all of the objects attached to its list. You might refactor the game to use std list objects or to prime the object pools for better performance in later levels when there are more objects. So here we are in the code of Rocket Ship Delta, and in the init game function you can see all of the different string list objects that get created and used for pools. And there's actually special string lists for the minimap as well. And then over in the cleanup game function, all of the pools get set to ownsObjects, and then they get destroyed, which means if we go up here at the very top, destroy is a template that we've added here which deletes them and sets them to null pointer. And then the other thing I want to show you is here is an example spawn function where it grabs an object from the pool, and if it doesn't exist it creates it. Here's the get pool function. Here it is. If it does exist it grabs it, otherwise it creates it and then returns it to this function, which uses the object and returns it to the result of the spawn projectile function in this case. Let's talk about animation. We covered the animation a bit already, but animation is implemented using the T-bitmap list animation component, which is built into the FireMonkey framework. T-bitmap list animation uses a sprite sheet which features each frame of an animation on a single bitmap. The frames are copied from the sprite sheet and drawn in place to create the animation. Creating a sprite sheet to use in C++ Builder can be tricky because a lot of the art tools out there export a sprite sheet in a different size than what C++ Builder is expecting. C++ Builder expects a sprite sheet that is exact width and height of the number of frames in your animation. You may have to trim down your exported sprite sheet before loading it into C++ Builder. There was one version of iOS which caused problems with the animations if they attempted to run while the game was being transitioned to the background. It created a new function called pause bitmap list animations, which loops through and pauses all the animations before the game is backgrounded. When the game enters the foreground again, the animations are all restarted. A side effect of this is that the games may now take less resources when in the background on some mobile devices. So I have Adobe Flash, which is good for animation, opened over here, and I have the explosion graphic set up here, and I've turned it into a symbol. So over here I have the symbol, and then, or a movie clip if you want to call it that, and then I can right click on it and I can do generate sprite sheet, and you will see that it creates all of the frames of the animation here on the single image, and you can also see that by default it sets the width and the height to 256 by 256. Now Rad Studio really doesn't like this size, so you'll need to cut, once you export it, you'll need to cut it down so it's this size only, and this extra space is not included in the sprite sheet when you export it, or after you export it, rather. Now over here in Rad Studio C++ Builder, I'm going to click on one of these enemy graphics, and I'm going to bring up its animation again. I showed you this before, but I'm going to bring this up again. The enemy is a little bit different than the explosions. So there are 3 across and 2 down, so a total of 6 animations there. That's the sprite sheet. And you can see the animation count is set to 6 because there were 6 of them, and then 2 rows. And again, with this one, it turns on using the trigger of is visible equals true. And then if we go over to the code, I have this set up. Here is the pause bitmap list animations, which you can pass true or false to, and it loops through the enemy list and the explosions list, and it will pause those animations or unpause them if you pass the other boolean in. And that is controlled by the handle app event, applications event, and it goes, if it becomes active, turn off the pause, and if it is is entering the background, pause all of the animations and stop the game loop. The final game we are going to talk about is called Space Rocks. Space Rocks is a classic arcade-style game where the player starts at the center of the screen surrounded by a number of asteroids. The player can rotate their spaceship left and right as well as accelerate forward. The player has an inertia from each acceleration which slows down over time. The goal of the game is to destroy the asteroids so you can move on to the next level. Each time you shoot one of the asteroids, it breaks up into smaller pieces. Additionally, there are alien spaceships which crisscross the screen and randomly shoot projectiles at the player to keep you on your toes. So I've got Space Rocks open here, and let's walk through the asset layout. So we've got the different rocks here, and the different rocks do not have an animation because in this game they rotate versus being animated. We have all 3 different rocks. You could add more rocks if you'd like. Here is the enemy character that randomly flies around. Here are the points power up. Here is the enemy projectile, the player projectile, and here's the player outside of the asset layout, and the background also outside of the asset layout. So now we're going to compile the game for Windows here and show you how it plays. We're going to click play, read the instructions, and I'm going to use the keyboard here, move around, fire at some of the asteroids. There's one of the guys flying by. I'm going to get him. I'm going to get that guy. Oh, I get hit by an asteroid. Oh. And I'm flying around, shooting all these rocks. The asteroids are exploding. Usually I don't move around, but I want to demonstrate the acceleration, and I've completed a level by destroying everything in that level. I'm going to continue a little bit, and you can see how my character was semi-transparent. There's the invulnerability, which is available in all of the games. That it's when you die, your character dies, that you go invulnerable, so that when you come back in the next iteration of your life, that you don't immediately get destroyed by some other character. You have a little bit of a leeway before you become invulnerable again. So now I'm moving on to the next level again, and that is Space Rocks. I'd also like to cover some of the other controls here that you see. There is the gyroscope button that you can toggle on and off for the accelerometer control. There is the sound and mute buttons. There is the TCP/IP control here, which does a check to see if you're online or not, so that it can decide whether it allows you to use app tethering or not. We have the music player over here. We have a style book, which is loaded up with one of the premium styles, and the other controls from the tethering, which we're going to talk about in a minute. The different various controls from the high scores system, and more controls from the tethering. And here is the game loop timer and the invulnerability timer and the fire button, the accelerate button in this game, the rotate left and right buttons. And over here was the label control, which I talked about, which displays the debug game loop milliseconds. I like to share a screenshot of an early version of Space Rocks so you can see it in its skeleton form before the graphics were applied. You can see how T-Rectangle is used. So in this one, we have the player character already filled in with the graphic. We have the player's projectiles, we have the rocks moving around, and we have the left and right rotate and the accelerate, or in this case it's probably the fire button. The accelerate button is probably not in the game in this early prototype. Let's talk about app tethering. App tethering is a group of components that comes with C++ Builder for easily communicating between your C++ Builder apps on different devices. You can connect via Bluetooth or over an IP network connection. Packets in the IP network connection are sent via the UDP protocol. The components in the games are set up to use the IP connection. App tethering is actually peer-to-peer, but in this implementation it acts as a client and server. Keep in mind that network congestion and your Wi-Fi signal quality will affect app tethering. The app tethering implementation within the 4 games allows you to run one device as a game controller or gamepad and a second device where the game is running. For example, you can have your Android phone set up as the gamepad controlling a game on your iPad, or you can have your iPad device be the game controller controlling the game running on a Mac OS X device connected to a big screen TV. You can even have your Windows machine be the gamepad and play the game on your iPad Pro using the keyboard from the Windows machine. The server side of the app tethering components are embedded in the main form, and the client side of the app tethering components are embedded in the gamepad frame. The game itself has actions set up for each of the control functions within the game. On the gamepad side, each button is set up to run one of the remote actions asynchronously. Press a button in the gamepad, the action is sent via app tethering, and the action gets executed in the game. Keep in mind that because the actions are sent asynchronously, you will need to thread synchronize any code within the actions that modifies the UI. You might enhance the game to include more robust app tethering support for connecting between devices or to use Bluetooth instead of IP networking. The current UI for app tethering in the games is functional, but could be expanded to better handle connection errors. So now I'm going to open up the gamepad and show you some of the gamepad code. And here's the gamepad code in the gamepad frame. We have a check remote profiles section that looks for the various different app tethering devices on the network and connects to them, and some other maintenance functions that app tethering uses. And you can, when you press the connect button, it runs this function, and here is the button action function. So this is tied to the various buttons. As you can see down here, each of the buttons on the frame is connected to runs through the button action function, and also same goes with the key down and key up events on the gamepad, and all of those send the information back to the button action function, which executes the app tethering run remote action async function. Keep scrolling down here, and there's also a clear buttons event, which when you disconnect or something along those lines, you clear the buttons so they're not stuck in the down position or something like that. And then if we switch over to the game and go into the code, well, let's switch back here. And so here are the server app tethering components, and here is the action list set up. And we can right-click the action list, see the action list editor, bring it over here. Here's the various actions that are set up. And if we move over into the code, we can see, so here is the action that gets executed on the server from the gamepad client when run remote action async is sent. And as you can see, I've got some comments in here to make sure that you thread synchronize if there's any UI changes that happen in here. So I have all of the controls sent to the various control events so that the various controls from the key down, from the gamepad, and from clicking the buttons on the screen all go to these events, so there's only one set of code for controlling the various events within the game. As you can see, all these events do is modify these different booleans, and then the game loop takes care of handling those actions based on if that boolean is true or false.
All right, so we're going to demonstrate app tethering. What we've got here is we have Rad Studio C++ Builder has SpaceRox open, and we're going to go over here to the Android target, and I'm going to select my Nexus 7 tablet device, and I'm going to deploy to that device. And what we're going to do is, once I deploy the app to the tablet, I'm going to compile the app again on Windows 32, and we're going to connect as a gamepad on the Nexus 7 tablet device to the kind of the server via app tethering on Windows. And then I'm going to control the Windows game from the app tethering tablet device, Android to Windows. So it's currently signing the APK file. It's installing the APK file on the device, and after that loads up, I will be able to compile to Windows. It takes a few seconds here for this to compile. Now it's going to load. All right, loaded FireMonkey, it loaded up the app. There is SpaceRox. I'm going to click over here to Windows, and I'm going to compile the Windows. And then I'm going to make sure that the app tethering server is on, and I'm going to go full screen. I'm going to go back to the main menu. I'm going to move forward into the instruction screen. I'm going to go to the gamepad, and I'm going to connect to the SpaceRox Windows machine. And then I'm going to hit fire here. And what we have set up is each of the kind of the default buttons of a screen are tied to the fire button, so that you can use the gamepad to move through the screen. You don't have to go back to the server side version of the app to move through some of the screens with the mouse and the keyboard or something like that. All right, so here I am. I have the tablet as the gamepad. I'm controlling it. The app is loaded up on Windows, full screen. I'm shooting at some SpaceRox. I'm going to use my acceleration there and get over here to this rock. So one other thing that the app does is, depending on your screen size, it just automatically resizes to fit that screen size. And so that's what. So on a full screen Windows machine like this, there's much more game real estate than on a tablet, for example. And so the game is much more spread out. So I'm just rocking around here, accelerating my rocket with the gamepad, shooting up some asteroids. I can kill all these asteroids. I'll be able to move on to the next level. There's a bonus. I'm going to go for that. Oh, missed it. Another one. And then we've got some, oh, here's an enemy. Plaster that guy. There's a SpaceRox over here. It runs up. I'm going to grab it right there. Get these two. Once I get all these rocks, I'll be able to move on and destroy all these enemies flying around. We move on to the next level. And all this is using UDP via app tethering, Android to Windows. And this last guy moving on to the next level. As you saw, that was level complete screen, and I pressed fire and it moved on to the next screen.
Let's talk about cross-platform sound. The FireMonkey framework comes with the T-Media Player component for playing audio and video files. The T-Media Player component is not very designed to play the quick sound effects you need in a game, but it works great for a music track. We used the T-Media Player component for the music and had to manually implement music looping as it is not built into the component. Additionally, when stopping and starting the music, we simply adjust the volume because the performance hit that happens when stopping and starting an audio file. We put together a cross-platform component called T-Audio Manager, where small sound files can be registered and played with ease. The T-Audio Manager component uses platform native APIs and ifdefs to play the sound files from a single source code on Android, iOS, Windows, and Mac OS X. On iOS, it imports 4 functions from the Apple Audio Toolbox framework. You must add this framework to your iOS SDK in the IDE before you will be able to compile the project to iOS. On the Android side, Audio Manager and Sound Pool from the Android SDK are used. On Mac OS X, an NS Sound object is used. And finally, on Windows, the SND Play Sound API call is used. Deploying sound files to each individual platform is slightly different. On iOS, you must deploy the files to the Startup Documents directory. On Android, you must deploy the files to the Assets internal directory. On Mac OS X, the directory is automatically configured to deploy to the Contents Resources Startup directory. Finally, for Windows, you need to manually copy the sound files, both star.wave and star.mp3 files, to the same directory as the executable. There is a ifdef within the FormCreate event, which defines where the sound files get loaded from. For Windows, you can use the path in the classic param_str0 function. For Mac OS X, the system IOUtils tpath get_home_path function corresponds with the deployment directory. And for Android and iOS, the system IOUtils tpath get_documents_path function corresponds with the deployment directory. You might enhance the game to include even more sound effects and even apply sound effects to the various buttons throughout the UI when they are selected. You could even implement a voice recognition control system for navigating the menus or some of the in-game functions. So I've got SpaceRocks open here, and I'm going to show you the code in the FormCreate event. And you can see we have the if defined plat MS Windows, then use the param_str0 function and extract the file path from that to set the data file path. And that's where it's going to load the sound files from. For Mac OS X, if it's not iOS, then you're going to use the get_home_path function. And then for everything else, if it's iOS, if it's Android, you're going to use the get_documents_path function. And so then I can go over into deployment, and you will see the various paths. If I sort here by type, you can see here are the audio files that I have set up in the deployment section, and those will get deployed to these different platforms. There's all the platforms, and they get deployed to each different platform, and you can customize the remote path or the deployment path for each of the different platforms. So for example, this is set on Windows. If I go over here to Android, you're going to see that the sound files are deployed to the Assets internal directory, and if I go over to iOS, you can see that the sound files, let's get this typer at the top, you can see the sound files are deployed to the Startup Documents directory, and finally if I go over to OS X, you can see the files are deployed to the Contents Resources Startup directory. So I'm going to close out deployment, and I'm going to go over to the Audio Manager header for the RT Audio Manager component. You can see the ifdef set up here. Here are the Android files that it needs. Here are the iOS files that it needs, and here are the Mac files that it needs. Here's the class itself, and it's got some various functions in here. You can add a sound, you can delete a sound, you can play a sound, and the destroy function is here, and the create function. And then here you can see on iOS we import the Audio Toolbox framework and then import these 4 functions. So you can see how to import functions from a Apple framework there. And then if we go over to the source file, we can see the various ifdefs. Here is where it loads it up. It creates a list here, and it destroys the list and the objects within it in that function. We add a sound. We've got our ifdefs in here. The various sounds are added. Here's for Android. It adds them up to the list. For iOS, it adds them to the list. Deleting sounds. And then if we get down here to play sound, it's got the Android defs, and it plays a sound here using the sound pool from Android SDK. On iOS, it uses these functions from the Audio Tool framework. On Mac, it uses NS Sound, and on the Windows, it uses this SND Play Sound function from the Windows API. And that's about it for this section on audio. Bringing it all together, the game's compiled to 4 different platforms from a single codebase. All 4 platforms can also talk to each other and control the games across devices. So now we're just going to demonstrate some various forms of that, different app tethering combinations here with the same app playing across different devices.
Alright, so now what I want to do is I've got C++ builder here, I've got Rocket Ship Delta loaded up in it. I'm going to deploy to each of the target platforms, just so you can see all of the platforms being deployed. I got my Nexus 7 here, and I got my iPad right next to it. So I'm gonna load up here the Nexus 7. I'm gonna deploy to the Nexus 7, and then right after that, I'm gonna deploy to the iPad, and then I'll run a Win32, Win64, and then I'd like to deploy to the Mac OS X too, but I'll need to move the camera for that, so I'll set up the deploy, and then I'll move the camera over and show you the Mac OS X version on a big screen TV. I got a Mac Mini connected to that. So we're deploying to the Android device right now, and then we'll move on to those other platforms. Single code base, single UI, all platforms. And it's installing on Nexus 7 right now. Alright, we've got it on the Nexus 7. Play here real quick. I got the gyroscope on, moving around. Shooting some guys. Crashed into that guy. Oh, I need a bomb. Oh yeah, I got all those guys. One shot. See, that's why we have the magic bomb and the warp. So you can. This game is kind of difficult. Alright, so now we're going to move on to the next platform. I'm going to go back out of this. I'm going to grab the iPad. Load that up. I'm going to deploy to the iPad. And it takes a minute here for it to deploy to the iPad, even though I've deployed it once already. Now it's deploying, like it's copying all the files, it's setting up all the icons, the splash screens. You can configure all those icons and splash screens yourself, have a custom icon on the iPad and the splash screen. You don't have to keep the FireMonkey Flame logo. It's launching Rocket Ship Delta now, the IPA file. So now we've got Rocket Ship Delta loaded up on our iPad 2. And we are going to click play, move through the instructions, and I like the accelerometer, so I'm going to turn that on and move around. Alright, shooting some guys, using the bomb, using the warp. Alright, let's move away, let's just keep away for a minute, try not to get destroyed. I'm going to use the wormhole, there's some more guys, use my bomb. And so using the accelerometer, move around. The accelerometer is really a good control mechanism for all of these games if you have it. For when you don't have it, you're using the keyboard or a mouse on a desktop machine, it works pretty good too, but on a mobile device, the accelerometer control is really where it's at. Points power out, missed it. Another one, I'm trying to get it here. Alright, got that guy shot at me. I think this guy is upgraded, that's why he's following me. And so you can see the parallax in the background there. There's 3 separate screens. Alright, I need a bomb. Oh yeah, killed all those guys. Alright, so there's a parallax, and you can see the separate screens here are 3 separate layers to the background. So that's what causes that effect. You can bring that parallax into some of the other games if you wanted. Alright, so here's the high score screen. Bring up the keyboard here. Type my name in. And this way. Hit OK. And so now a high score there. Continue. Main menu. So that is playing on the iPad 2. We're going to switch over to Win32. We're going to hit play. So this one I'm going to play with the keyboard, and I'm going to make this a little bit bigger. Stretch out the gameplay area. You see C++ builder in the background. Play. Continue. I'm going to use the keyboard in this one. And so So this is an interesting effect. You can see that on this width of screen, it really doesn't offer very large play area. This game is mainly designed for mobile devices where you can scroll all the way. Alright, so I'm going to hit this wormhole. And I'm going to use the bomb with X key. And then the C key does the warp. So I'm going to warp all over the place. Get this guy level complete. Alright, now I'm going to switch over to Windows 64. Compile it for that. And I'm going to hit play. Continue. And I'm going to play this one with the mouse. Move around, crash into that guy. Much harder to use. All right, I'm use the fire from the keyboard while I move around with the mouse. That's just too difficult. All right, this guy's shooting at me. He probably upgraded. He probably captured one of these guys here at the bottom. These guys are at the bottom. This is the planet I'm supposed to be defending. So at the end of each level on both sides, you have the plasma fence. Use a bomb here. Got all those guys. You have the plasma fence, which keeps me from moving outside the gameplay area there. You can see the bombs, how many bombs I have over here, how many lives, my health, the points, and all the different. Over here is the milliseconds, how long each game loop takes. So that's 64. And then I'm going to go over here and I'm going to deploy to the Mac. Alright, so I'm going to compile to the Mac device. It's going to load up all the files, send it to the Mac. Alright, so I've got the game deployed over here on my Mac Mini, which is connected to a big screen TV. And I've got my iPad here, and it's connected via app tethering the gamepad. So I'm going to hit the fire button and move into the game, and then I'm going to move around using the iPad on the iMac. Hit this warp. There's a guy. I'm going to use the... I don't need to use the bomb yet. Alright. Bomb, I'm going to use the warp, bomb, warp, quick, shoot that guy. Alright, so you can see all the guys on the mini-map there, and you can see me controlling the ship using the gamepad on the iPad. Alright, that guy's I got that guy. Alright, so I saved that guy. So the character's falling down, I'm going to shoot those guys. And get this guy. Bomb. Oh, I'm out of bombs. Uh-oh. That's not good. That's not good. 3 health left and 1 spaceship left. I'll go up here and try to get this guy. Got him. Alright, that guy's going to upgrade. Shooting at me. Alright, so you can see the parallax again in the background. And use the warped. And that's Rocket Ship Delta deployed to all 4 platforms using the same source code and UI. I'd also like to show using the iPad here and the Android device using the gamepad between Android and iOS. So I've got the iPad set up as the server, and over here on my Android device I'm going to use the gamepad as the client. I'm going to set that iPad there, go to gamepad on the Android device. I'm going to connect to the iPad, and then I'm going to start controlling the iPad from the Android device. I'm going to fly around and go through this warp, use the bomb, take out those guys, crash into that guy. As you can see, I'm controlling, using the gamepad, I'm controlling the iPad device. So that's cross-platform app tethering. I think I'm out of bombs. Uh-oh. Use this warp. I'm not doing so hot. So there you have cross-platform app tethering. I'm also going to show using the keyboard on Windows. So I'm going to launch Rocketship Delta on Windows here from C++ Builder. I'm going to go to Gamepad, and I got my iPad here running the server, app tethering server. I'm going to connect, and now I'm connected, and I'm going to push fire on the keyboard. So I'm using the keyboard right now with one hand to fly around on the iPad with the keyboard on Windows. Uh-oh, I need the bomb key here. That's the warp key. Alright, there's the bomb key. Uh-oh, they're coming for me. Alright. And there you have it. That is using the keyboard on Windows to control an iPad.
Here's the acknowledgements. Quite a few developers around the world worked on these 4 games, so I'd just like to say thank you to everyone. In case you missed it, you can access the source code at embt.co/CPP Games 2016. That's a bit for now. Thanks.
Okay, thank you, Eli, for that fun session. Lots of cool stuff in there. I actually learned quite a bit. I've tried doing game development before, and I always thought the game loop was something I'd never quite figured out the way to go. So it was cool to see that you'd how you set that up, and you talked about some of the alternatives and stuff like that. So,
yep. So if anybody has any other questions, I'm trying to answer them here.
So we'll go through some of these questions here that you already answered as people are typing some more questions in. One thing we'll point out that is that you developed this with the full C++ builder. So some of the features like mobile development and the databases aren't available in Starter, which is, so just so everybody knows that this will compile without some changes in the other in Starter Edition.
Yeah, mainly I have the Pro Edition with the mobile add-on.
Yep. So there's where the source code is available if everyone wants to check that out. And like I said, you'll need the Pro with mobile at least to build these. Okay. Oops, what did I click?
I'd like you to explain a little about the game loop. I mean, basically, you could, like I said, you could use a thread for the game loop, or just use a timer set at 36 milliseconds, and that gives you a pretty decent frame rate. But basically, you just have all these booleans and other variables that you change, and then the game loop checks all of those variables and updates everything within the game during those 36 milliseconds.
So is the idea like if I press the up arrow, that it sets a Boolean saying, hey, they pressed up arrow, and then the next game loop comes through and says, oh, we're moving up now? Is that what happens?
Right. So it would only move your ship during that game loop, say 10 pixels or something. But then if you stack all those frames together, then you moved quite a few amount of space in 1 second or something like that.
So why 36 milliseconds? Is that arbitrary, or is there some magic math behind there?
There's some magic math. 36. If I can do the math here. That gets you 27 frames a second. And if the human eye can see 25, then you're pretty good at
Okay. Now, do you make use of threading or task or anything like that in here at all, or is it all just done with the timer and the game loop?
The only threading that I do, there's a classic version, the C++ 11 version, but there is one instance where I use an anonymous thread, and I do that in order to check whether TCP/IP or I check whether an internet connection is there, basically, and I do that in an anonymous thread because you don't want that to block. And so the rest of the threading, I don't believe there's much else in there. Well, all right. So the run remote action in older versions of C++ Builder, like C++ Builder Seattle, I didn't need, there was not an asynchronous function for that, but now it's asynchronous, and so it sends it asynchronously, and you have to thread synchronize those calls when they come in to the game loop if you use a UI element in there. So, and then the rest, I don't think there's much threading anywhere else. I mean, the game, FireMonkey takes care of it, so unless it's being blocked somewhere, you don't really need to use threading.
Sure. No, that makes sense. Let's see. So everybody really liked your speakers that you're using there. I see you posted a link to Amazon, the Sound Original Dancing Water Stereo speakers. I actually saw those at the store one day, and they look really cool.
The only issue with them is that the sound is really loud on them, so I would need like another sound, like a hardware sound control on them, because otherwise it's like playing music through them is really, really loud.
Interesting.
So no one else in the office appreciates it.
There's a question about storing objects in T-string list or T-dictionary. Which do you prefer? Which do you recommend?
My favorite is T-string list. I don't know that I've even investigated T-dictionary. I've been using T-string list since, I don't know, 18 years now or something like that. I just use it for everything.
Yeah.
So there is a T-object list, and I looked at using that, but I wanted to use T-string list because if you were going to add a boss character, or if you were going to have some other kind of modifications to the objects in the game, or if you want to look them up based on the string, you have that option. You could add in a string, and then you could do a lookup based on the string, and you'd get that object back right away instead of having to do some other type of lookup to get those objects.
Yeah, I really like the T-string list too because it's so flexible. But I'll admit that I've actually started using T-dictionary, and it might actually be better. Even though the T-string list is cool, the T-dictionary might actually be better because you can index it by string, or you can index it by integer, or you can index it by whatever, and then you can also hard code it to a specific type of object, so it only accepts certain types of objects. So it saves you some of the typecasting that can cause some mistakes. Let's see, very cool. Lots of comments that this is really cool stuff. Question about the Steam SDK. If support for that. Have you looked at that at all?
I haven't looked at the Steam SDK. I mainly looked at different mobile SDKs and stuff like that, and nothing on Steam really. But I would assume, I mean, if it's just whatever it is, a Windows DLL, if you're working for Windows, then you just should be able to interface with it, especially in C++ Builder, because there should be, I don't know, Steam SDK header files for the DLL. If that's what they provide, I'm not sure.
Yeah. There's some questions, confusion around the way the sprite sheet is being done. You want to elaborate on it a little more?
All right, so the sprite sheet, so some of the other tools that create it, they create it in I'm going to call it a standard size, or actually they create it in a texture size. So 256 by 256, that would be a texture that gets loaded directly in that size into your 3D card, or your if it was on mobile, your 3D hardware. And so that's why they export those sizes. Now, C++ Builder, I'm not sure that it works the same way as far as loading a texture in, and so that's why it may just use, it just wants the exact width of each frame combined, and so if, say, you had 3 frames across and 3 frames down like I showed in the webinar, and just as an example, say they had 50 pixels each. So you'd have 3 frames across, that's 150 pixels, and then 3 frames down, that's 150 pixels. So you'd end up with 150 by 150, and those configuration options on the animation, I'll load up one of the, and check it. All right, those configuration options in the IDE, the animation count, the animation row count, those tell that the T-bitmap list animation how many images are there. And so it just goes and cuts out those frames, and then it just plays them on top of each other like it's an animated GIF.
Oh, okay. So okay. And so that's just an animation that does that then. That's cool.
Right. I mean, it's kind of like the control that holds all the images in the image list. Kind of like an image list, except for it animates them when it comes out instead of just holding them separately.
Now, I may have missed this part. I saw you were doing frames, but it looked like, were your frames overlaying with transparency? Is that what you're doing there for like the controls and stuff like that? The gamepad?
So each frame is, the frame itself doesn't really get, like the frame background doesn't get drawn. It really is transparent. So if you drop a frame onto your main form, there's nothing there. Like if there was nothing in the frame and you dropped it on the main form, you would see nothing. So what I did is I put a T layout inside each of the frames, and so then that T layout is aligned to client, and of course T layout is invisible, and so that's it aligns the client, or actually it aligns the content, and so it just aligns the full screen of your form, and then when you make the frame visible, it's there, and all of the buttons and things that were part of it are all there as well. And then when you hide it, they're all gone again, so that's why you're able to use set stage to turn them on and off, and it makes it really easy to do that.
Okay, that's really cool. I guess I've never tried putting a frame down without something in it and realizing there was nothing there to see. So the question here about, you use the T rectangle for all of your shapes. What if you wanted to handle irregular shapes? How would you handle that? What would be the way to do that?
Well, so
Collision detection.
There are ways to do it, but pixel-to-pixel collision calculations is rather intensive for mobile devices, and so if you were going to do that, you should really use like a physics engine like Box2D, which is available for the product. There are other optimizations that you can do, like for example, you can do a distance calculation between the two objects, and if you know the diameter and the radius of an object, then you can figure out, okay, well these objects are really far enough away from each other that I really don't have to do a pixel by pixel collision detection, and then when they come within range of each other, you could start doing that, and that is an optimization that saves you on performance. But once you start getting really close to each other and you do pixel by pixel, it can be expensive performance-wise. I mean, I've done this in other game platforms, and that's what I found there as well. So it's not just this platform; it's pretty much all of them. And maybe there's more optimized algorithms out there that do it, or there's the other things that they do, or other options that are available are it can turn a Actually, this is available for Box2D. It can turn an irregular image or a bitmap into like a 3D object using polygons, and then it just does those polygon collision detection versus doing pixel by pixel. So there's lots of ways around it. This is not specifically addressed in this game or in these games. Basically, we just use the rectangular collision detection.
What would be the impact on the frames per second if you'd used an animated background?
I'm not sure on that. I would assume would run pretty decently. I mean, FireMonkey it does use OpenGL, and there's all the FireMonkey effects that you can put on stuff, and they run, and like you can do animated tabs between switching from one tab to another. It kind of depends on if it's a bitmap or if it's drawing at every frame, and so I would say it also depends on the screen size. I would think, like, okay, if you full screen on Windows, there's probably enough power in your desktop machine that's going to make a difference, but if you had an iPad Pro maybe and you used a huge background and you were animating that, you might run into some frame rate issues. You just have to test it out and see what works on the different devices and what doesn't.
So did you require specific hardware for doing the Android development? Or is it just
No.
regular Android devices?
It was just an Android Nexus 7. I also have a Samsung device here that I could have used, and I just plugged it in with a USB cable, and that was it, connected to a Windows machine.
Okay. So there was questions here about whether there's a Delphi versions of these as well. There are. We'll make those available in the future, but today we're doing the C++ bootcamp, so we have the C++ versions on here.
Yeah, Steam for OS X. I'm sure that there is a Mac framework for Steam, and you can probably import it using the SDK transform tool that comes with C++ Builder Berlin, and then you would have access to that SDK without me investigating further, like how their SDK is delivered, whether it's, I don't know, maybe it's Java, I'm not sure.
So now you in your bio you talked about that you develop games on a number of different platforms with different development tools. What are some of the advantages and some of the reasons that you like using Rad Studio to do these games?
I would say that for me it's the form builder. It's the form designer. It's the visual design part of it. And I mean, and T-frames, which you, Jim, actually set me onto T-frames a few years ago, and now I use T-frames quite a bit because it allows you to segment your code. It allows you to segment your code out and to segment your UI out, but it's still visually designed. So you're visually designing a component instead of writing all the code to, oh, this component is here, and I'm going to write the height and the width in code. You just go in and create it, and you're done. So for me, it really is the form designer. Like that's the rapid application development. That's the part that keeps me with these tools.
Yeah, I agree. I love the fact every now and then I'm like, here, oh, this such and such tool. Oh, great! And I go try it. I'm like, where's my form designer? It spoils you.
It does. I mean, you're like, I don't understand. How come these other tools don't make it as easy as it should be?
Yeah. Yeah. And the frames are very cool. The way you used it here is very creative. I really like that. So, yeah, I'm glad you got some good use out of that. And now, so you used app tethering for connecting these together. And I've seen other games that do multiplayer where you can connect devices, connection, and most of them won't do, even if they have an Android and iOS version of the app, they won't do connection between the two because they said the libraries don't support it. But yet here you're connecting between Windows and an iPhone or an iPad without any trouble at all. I thought that's pretty cool.
Well, and that's I'm gonna call it. Well, maybe that's vendor lock-in because okay, if you have an iOS library, you can talk to other iOS devices, or I mean, even if it's a third-party vendor. But they mainly support iOS, so they only offer an iOS library, and if that library is not over on Android, then you're not going to get cross-platform connection. But because the C++ builder and FireMonkey is cross-platform, you're able to use app tethering across all the platforms. They all talk to each other.
So now on the forum,
sorry, Jim and Eli, there's been several questions about you trying to compile these games with the starter edition, and it looks to me, I did a little quick check. The doing FireDAC, so doing the game saving, high score saving, that would have to be removed, right? Or somehow if-def, it's harder to if-def forms. Is there any other advice for people, Eli, on how to get these games to work with the starter edition?
All right, so for the starter edition, I mean, if it doesn't have FireDAC, you could just remove the high score screen and change at the end of the game, change the set stage from send to high score. You could change it to set to game over, and then that you could remove the FireDAC usage by removing that frame. Is app tethering available in the starter edition?
It looks like it may not be available. I thought it was, but I'm not sure. It looks like it may not be available. So
anyway, you get the starter edition for free, but you can also download the Pro version and use it for 30 days and use all the stuff as well. So I mean, the trial is there available too.
yeah. Yep. So I will look and see if there's like what I can do to make these work under a starter. Someone else may be able to go in and just, you know, if you really want to make them work, I'm sure you can just, like you guys said, just start commenting things out and removing them, remove the high score screen and stuff like that, and you probably get it working pretty quickly. If I can, I'll make a fork of it or something like that that works under a starter. So on this form, you have a 0 milliseconds parameter being displayed. What is that for?
All right, so the 0 milliseconds, so that is what we do is at the beginning of the game loop we take the time, and at the end of the game loop we take the time, and then we subtract those two numbers. And so that's the milliseconds that the game loop takes to complete, and then it gets displayed in that T label. And so on Windows, on a very fast machine, of course, it's going to take 0 milliseconds because it's just doing it's not doing that whole lot. But on mobile devices, it's more useful because it tells you if there's spikes in the milliseconds. It tells you what the average currently is, because you can see it. I mean, if it's averaging 6 milliseconds, you know you're good because that's not more than 36. So if it spikes past that, okay, maybe you should do some optimization to reduce that. And so one suggested optimization is you could preload the object pools with objects. I don't think that I did that in here because it wasn't necessary, but you could load up or pre-create 10 projectile objects in the object pool, and then it wouldn't have to do that at runtime, and not say at runtime, but it wouldn't have to do that when it needed an extra one because it would already be created in there. You wouldn't get that hit from creating an object.
Okay. So okay, that makes sense. So now, if you have to have a Mac to do the iOS development, are there any ways around that you're aware of?
You can use macincloud.com. I used to use it before I got a Mac Mini, and for the most part, it was pretty decent. The upload speed, like if you were doing debugging to Mac and Cloud, the debug file for iOS, I don't know, it's like 100 megs or something, but if you had a really fast connection, you wouldn't notice. I had a slower connection, so I didn't really use, I mainly debugged on Win32, and then once you're, for the most part, I don't know, 95% done, then you can start deploying to the Mac and seeing what other issues, or deploying to iOS, and seeing what other issues are iOS specific. But I mean, FireMonkey is cross-platform. Develop it in Win32 because it's super fast to compile, and then start moving out to the other platforms when needed. Unless you need to use a native control, then of course you're going to have to deploy right away.
Yeah, Jim, I put a link to the platform support that's on the DocWiki that tells you what versions of the operating systems for different platforms that we support. I mean, you can pick up an Intel processor-based Mac Mini very cheap, a used one, for example, on eBay or Craigslist or wherever, you know, $200, $250. So it's not much. You don't need a whole big full Macintosh. You just need an Intel-based Mac Mini running that can run a recent version of Mac OS and Xcode, and then you're set. That's what a lot of the engineers use as well. They don't all have MacBook Pros or Macintosh servers, so you know, search for used Mac Mini Intel processor, and that'll take care of that. For Android, since we have the Android SDK on Windows with the IDE, then there's nothing you need to do there other than have an Android device.
Yeah, and you can technically go with the Android emulator, but it's really slow because of the way the emulator technology works. But there are some tricks. I have some posts on my blog about how to make that a little bit faster.
There's a question here about the license on people being able to reuse the graphics and the sounds and the music from these demos. And basically, whatever the license is on all the other Embarcadero demos, I'm not quite sure, but all the sounds and the music and the graphics are licensed just like the other demos.
Yeah, so if you own a license to our products, you can use these in your applications. It probably yeah.
I created the music specifically for these demos, and I also created the sounds using a sound generator tool specifically for these demos. So there's no other. It's not like there's some musician somewhere that's going to complain that there's a license that you're using. No, these were specifically created for you guys to use with the demos based on the license that the Embarcadero demos provide.
So here's another question about the Delphi version of these. They're not publicly posted yet, the Delphi versions of the games. Maybe I'll see if I can get post those next week. Later, maybe next week. But if you don't find them, Kevin, just email me, jim.mckeith@embarcadero.com, or any of us, and we'll see if we can get them posted for you. So a comment here, Eli, thank you so much for these great games and presentations. As I see here, more step-by-step gaming examples are needed for developers. Yeah, more we can do for developers is always great, more step-by-step stuff. But yeah, these are great. I learned a lot in here. Can you have multiple tablets devices tethered as controllers at the same time?
So yes, and I've done that. I've connected, so I have my Windows tethering open, or I had technically the server version of the app running on Windows, and then I had my Android device and my iOS device both running at the same time and both tethered to the Windows server, and they could both control it at the same time. So like one guy could push the fire button, one guy could move the character around. So it does support that, because technically app tethering is peer-to-peer, and so that's why it's able to support that.
Okay, that's cool. Yeah, I've played with app tethering some, and there's a lot of fun stuff you can do because it is peer-to-peer, and you can do all these different things. And one thing that's cool, because it is peer-to-peer actually, is that you can initiate the connection from either side, and then once you're connected, you can send the commands either direction as well.
Yeah, and the actions is what made it really easy, because you just execute an action or a remote action and you're done. I mean, that was what made it really easy.
Yep. Okay. I think we've gotten through the questions. But so now you could use that tethering to make a multiplayer game too, right?
I would say so. I mean, so if you had the server, or if you had the main game running on Windows, you could do a split screen there, or you could even, you need a split screen if you had two rocket ship characters in Space Rocks, and mainly what you would have to do is there is a T player object in the game, and so what you could do, that was one reason why I made it an object. What you could do is or a T player data. So there's a T player data, and if you created two T player datas, player 1 and player 2, then you could hold those datas for each of them, and one game controller could connect and say, okay, I'm player 1, and the second game controller could connect and say, okay, I'm player 2. Then both of those rocket ships could show up, and they could both control themselves and fire. And technically, there wouldn't be much more to making it multiplayer than that. As far as connecting over the internet versus, because app tethering is kind of a local subnet system, connecting on the internet, you could use, I don't know, you could use REST, you could use WebSockets, you could use the TCP/IP components. You could use XMPP components to do like a simple kind of this is the key that I'm sending and execute it, just like app tethering, but just send one key at a time or one character at a time. So
Yeah.
there's lots of different ways to do it.
Yeah. The app tethering, they actually expanded it to work over the internet because some people were like, wait, I want to do it over the internet. But it does not have the auto discovery. You're typing the IP address up manually. But once you did that, you could connect over the internet. It doesn't have the, because it's designed for local network, though, it doesn't have the some of the things around reconnecting if it loses connections or something like that, which, you know, you can. If you're keeping a socket open over the internet, you can lose that. So there was a comment here about app tethering using UDP packets and what about packet loss. So the way app tethering actually uses both UDP and TCP. It uses UDP for discovery, and so it does a broadcast on UDP to discover the other clients to connect to. But then once it makes the connection, it actually opens a single TCP IP socket and sends TCP packets over that socket. So it uses a combination of both. So during discovery, packet loss is okay, but then once discovery make connection, then it uses TCP at that point.
And so that would, like if someone built multiplayer with this, that would affect how your multiplayer was too. If you had a bad connection and it was TCP IP, then yes, you'd experience some lag if you didn't take that into account.
Yep. Okay, let's see if there's...
Yeah, the source code is, if you don't have it yet, it's available at that URL.
Yeah, you can go there and get it in GitHub. And then like Eli mentioned, there's both the classic C++ version and the C++ 11 version of it available. And they're all in the same folder. It's just one project file, or one repository on GitHub. So why do you use the Indy TCP socket to see if you're online? How does that work for that?
Well, so I use that to check to see if there is an internet connection available to the app. And the reason for that is that app tethering wasn't very happy if you tried to turn it on and there's no internet connection. So the easiest way to get around that was just to detect if there is an internet connection by connecting to an IP address or a URL and seeing if there is one existing. And there's other ways to do it on each individual device. You can check the various APIs and detect if, okay, is Wi-Fi on an Android device? Is this on an iOS device? And so all that code you could put in there, but the easiest way is just to send out a TCP connection and see if it's open or not.
Okay, so yeah, all right, that makes sense. I was trying to think if there was maybe some sort of command on that one that's like, are you online or something like that. I didn't know that was there. But you're right, just opening a connection someplace to do the job. So I see Ken's asking if there's any significant technical support issues deploying mobile apps built with FireMonkey to different devices and countries. It does require, what is it, Android 4 or newer, and with Neon support, and then it's the iPhone 4 or newer, I believe, on the iPhone side. It does work with the newer Atom processors for the very few of those that are out there. And Neon is one misconception some people have is most newer devices don't list Neon because Neon was incorporated into the standard now, and so it's only for really old Android devices that being Neon or not is an issue. All Android devices today are Neon. I've looked into a lot of them, and every single one of them I've seen are Neon now, if they're actual devices being made today. So what is it? 99% of all Android devices are going to run FireMonkey applications with no problem. I actually did a blog post on that recently because I still get people occasionally saying, "Oh, it doesn't work on half of the devices." No, it never was that low. It's over 99% of them work. And I have a collection of, I like collecting odd Android devices like Android Wear watches or set-top boxes. the Amazon Fire TV stick, things like that. Plug them in there. They all just show up, and you're able to deploy apps on them just like anything else. So it works most everywhere.
So Patrick's asking about simulated depth and collision detection. The collision detection is pretty simple. I mean, there's just a function in there. It just checks the bounds of the rectangle against the other bounds. And there's other ways to optimize that. You can check the distance between the centers of the two rectangles, and then you can check the radius. And if you do that calculation, you'll know how close they are to each other. And if they're way far apart, then you don't have to do anything. You just know they're far away. And then as far as simulating depth, that's what the parallax does. Basically, it's just 3 different layers, and in this version, the front layer is quite large, and then the next layer is smaller, and then the farthest layer is even smaller, and then it just moves it in the opposite direction of that you're moving, and so your eyes detect it and make it feel like that there's depth. I think it's a really cool effect. I love the parallax.
I'll have to play with that because that's something I was actually curious about. So, because that's basic 3D depth there. I mean, it's not full 3D. 3D is one of those loaded terms because really it's a two-dimensional screen. So you can't do 3D on a two-dimensional screen, but everything you do makes it look more 3D that we call 3D. So that's, yeah, very cool.
Yeah, it's just an illusion of 3D.
It's like the, what is the one they do where they take 2 pictures from 2 different angles, but they overlay them and they flip them back and forth, and it makes it look 3D by just switching between two different points of view in the same spot.
Right, right.
It's just a bunch of illusions, exactly. Let's see. There's lots of comments here that everybody's excited to see these cool multi-platform game examples to show off the multi-platform potential. I think it's great. I love that you're like, oh, here, we'll just build it and run it on an Android device. Now it's running on an iPad. That's one thing I love about FireMonkey is that you're able to do that sort of thing.
Well, I really like the align and the anchor controls because they just allow you to build one UI instead of, oh, let's build for this screen size and then let's build for this screen size and do all this other work. When you don't need to do that, you just build one layout, you set up your lines, and it just auto sizes to the screen. Now, I did notice in Rocket Ship Delta, it looks like I do use some manual calculations there to get the width correctly on the game space, and they're really set up for mobile, and it didn't, in my demo, it didn't really work out on the big screen TV, so that's why I had it thinned up. But you could easily refactor that, so it would probably work great on a big screen TV as well.
Yeah, and that's what I found is that generally speaking, with using the align and anchors and the grid layouts and stuff like that, you can get majority of the way there for the majority of screens, and then you're going to have a couple screens you're like, oh, I need to tweak this just a bit or this just a bit. And in the Pro and Higher edition with mobile, you have the ability to use the multi-device layouts, Fire UI stuff we have where you can tweak the layouts on different platforms, and that will get you the rest of the way usually. And if not, you can try a little bit of code. But it's way better, even with Apple's Xcode and UI Builder, you end up having to build a separate UI for iPhone and iPad, and then on Android it's the same thing. For each different layout, you're going to be building different screens to really get it to look nice. So it's a huge improvement off of that. Well, I think we've gotten through the questions here. I don't see a lot that need to be addressed.
There was something else I was going to say. So what was interesting, so when you rotate your device, I also had to take that into account. And so there's some various swap XY functions in a lot of the games where they allow you to rotate the device and you can just keep playing. Like it takes that into account. And so but before that, you would be playing sideways. And so I wanted to take that into account, make it you could rotate the device all the way around and it would resize to that screen regardless of whether it was a portrait view or a landscape view. And so that was actually kind of difficult to get right because the different devices are all different. They rotate and they send out these events and stuff. So that was pretty tricky to get right. But now that they're right in the various games, it looks like they work pretty good. So yes, the C++ 11 features work in the C-Lang compiler, which is in the normal versions. The classic versions of the games don't. They're set to the classic compiler.
So there's a question about app tethering. So again, it uses UDP, and then once it discovers, it makes a TCP/IP connection in order to send commands and data back and forth. And actually, if you look into the samples, that you'll need to, I guess, the Pro with mobile or the trial edition, because doesn't work as starter. But if you look at the sample, there's actually a sample where it sends images from the camera or screenshots and stuff like that between devices using app tethering. So it's not streaming, but it is sending large amounts of data between the two as images. And then also it works with both network connection as well as Bluetooth Classic, which works on all platforms except iPhone, iOS.
And just to note, you can also, if you know the specific TCP/IP address of a tether target, you can specify a TCP/IP address and go direct to that tether target. You have those three choices. Just UDP find one or find multiple. David, I did a blog post a while ago. If you search for find tethering, app tethering, I did a sample blog post. I'll have to find that for the log of links, but it was I would broadcast out, find all the app tethers, and then display all the different machines that had it. But you have your choice of the network, Bluetooth Classic, and a specific TCP/IP address.
And you can also set up a password on each app tethering app so that it can only connect to another app with the same password, and that keeps the conflicts down a little bit.
There are also encryption hooks. You can intercept, send, and receive for app tethering if you need to encrypt the data. Usually you're inside your own firewall, for example, because it's inside of the subnet. But with the TCP/IP, you can go outside, so you can intercept the send and receive data as well. And for encryption, in the case of app tethering, you just use whatever algorithms you want. There's no built-in specific encryption. There's just the event hooks. So put down the tether manager and the tether profile and look at the event, the on events, and you'll see the before send, on receive, and so on.
Yeah, and the reason the app tethering was originally designed for local network, with the idea being that you didn't need to encrypt on a local network, but then some people wanted to connect remotely, so the encryption was kind of added later. Okay. I think I'm gonna look again. I always say that, and then a couple more questions sneak in on me.
So that one question about if there are benchmarks of FMX. There's like a like an Android, I'm going to call it a game benchmark app that I've used that it came out pretty decently. And then also on iOS there are Apple tools, I believe, that do can check for memory leaks, and they might do benchmarking as well. I'm not sure. But I don't have any of that information. That's kind of why I have the timer count in there, so you can see that if it goes past, I mean, as long as it's looking visually decent and it's not going past that 36 milliseconds, for me that's what counts. If you're really going for performance, you could go directly to OpenGL and really stick it with the performance on that directly.
Right, yeah. The FireMonkey framework, while it's fairly performant, it's not really designed around game development. Clearly, you can make games with it, but so there are ways you can go around the FireMonkey framework, like you said, straight to OpenGL to get really high performance. And I've seen some really cool stuff people have done with Delphi or C++ Builder and done some amazing games with some amazing effects and stuff like that. So it's all possible, but it's just a matter of at what level do you want to work with, right? Do you want to work with the nice form designer like Eli just shows here with the being able to prototype things right there in the form designer, or do you want to go down low level and talk to the OpenGL stuff directly? So. Okay. Let me check again.
Have you tested the apps under Remix OS on ARM and x86? I have not. There was some emulators I used to test on BlueStacks, I believe was one of them, but I haven't tested on that recently, mainly because the Android devices just work. I mean, I just send it to my Nexus 7, or I send it to my phone device, Android phone device, and it just works.
Yeah, I've tested with a few emulators, but just the fact an emulator is never going to be a full replacement for testing it on device, and it's so easy to test it on device. I just do test on device anymore. I actually taught a class on Android development with Java a few years back, and nobody cares about the emulator. They only used it. Everybody did 90% of their testing on devices, just because it's easy to do, and everybody has a device. And then would only use the emulator for testing strange, odd screen resolutions or something like that. Is the only time they used emulator. So most developers are testing right on device for Android.
Yeah, I did 4 Android apps directly, and they kind of used a web view in them, and that's all I did. I just sent it directly because the emulator, and that was a couple years ago, maybe 3 or 4 years ago, maybe even more, and it was just so slow on the emulator that I think it's gotten better, but it was just not even worth it to test on the emulator.
Yeah. Yep. All right. Well, thank you, Eli, for these games and for this presentation. It was a very educational, informative, and looked like a lot of fun. Looking forward to playing with these games some more and possibly making some variations on them with some different graphics or something like that for a starter, and then maybe I can actually build up a whole new game with them at some point. That'd be cool.
Yeah, I'm looking forward to see what other people do with these and release out there. Different versions, bigger bosses, more levels.
Yeah.
Let's see it.
So they're all on GitHub, so everybody can go out there and fork them on GitHub and play with them and have a good time and do some cool things. So this is going to be exciting to see what everybody's up to. And there is Delphi versions of these that will release maybe next week or so. But right now we're doing the C++ Bootcamp, so we're doing the C++ version of the games, but the Delphi versions will be released at some point in the future, hopefully. All right, fantastic. Thanks so much, everybody, for joining us, and we'll see you all back tomorrow for the last day, which is going to be stepping up to mobile, which is going to build on some of the stuff Eli talked about today, but it's really going to look at prototyping your app on Windows with the Starter Edition and all of the stuff you can do and be ready to go with on Windows with Starter. And then when you're finally ready, you can make the jump to Professional with the mobile add-on pack or Enterprise and actually deploy to mobile devices and find that your app is most of the way done. There's most of it you can do already in Starter as far as prototyping it and such. So look forward to seeing you all tomorrow, and we will talk to you later. Oh, there's one more question here that I will answer. It says, what about Android x86 devices? There were some Atom-based. Do you support them? So we don't directly support Android on Intel. It was just never a large market share, and actually now Intel's discontinued it. But Intel did introduce libhoudini. Libhoudini does emulate ARM code on the Atom processor, and I've tested it. I have an Android Intel device, which I got right before they discontinued them, and it worked just fine. I think there was one strange thing where the title bar didn't show up correctly or something like that, but it was easy enough to fix in my code. So yes, their tech they're not officially supported, but unofficially they work fine. Okay, and with that, we will talk to you all tomorrow. Take care, and bye, everybody.
Thanks.